Hi everyone, welcome back to my channel. So today we're gonna start with a new video where we're gonna discuss about the security concepts which will be required in SD-WAN. So today we will learn the network security concepts, especially related to authentication. So we can see this topology where the edge routers are connected to the transport link, which is MPLS or internet, and then connected to the controllers. The controllers we have uh, vManage, vSmart, and vBond. Let's suppose my SD-WAN network is working fine. Okay, working fine means all the controllers, as in like vManage, vSmart, and vBond are up and running. Okay, and all VH routers, the edge routers we have here, VH1, 2, 3, and 4 are all up and working fine. If we want to add a new VH router in the SD-WAN network, okay, so can any new VH router come in and join my SD-WAN fabric? Okay, so if the router can join, okay, if the router wants to join the SD-WAN fabric, then it must fulfill the security requirements. Okay, but if anyone can join, then it will disturb my network and cause a problem. Okay, so that means not all the routers can directly come in and join the SD-WAN fabric. Okay, so first is it has to comply on the security requirements. Okay, and then once it will fulfill the security requirement, then it can go ahead and join the SD-WAN fabric network. So now the question comes, what security measures I need to put in place in SD-WAN to restrict unauthorized device to join the network? We need to understand the security mechanism the SD-WAN solution is using. Okay, and once we know the security mechanism which SD-WAN solution is using, then in my coming videos we'll see and understand how to build all these three controllers, which are uh, vManage, vSmart, and vBond from scratch. Okay, and we will set up the lab to bring the SD-WAN fabric also. So the security mechanism which the SD-WAN solution is using, um, that comes starting with authentication. Okay, so means any device which is planning to join the SD-WAN network must authenticate itself, okay, before it will join the SD-WAN fabric. So means the VH router, the VH router is planning to join the SD-WAN network. If this VH router is claiming that it should join this SD-WAN fabric, okay, that means this VH router should be authentic one. Okay, so let's suppose if if vbond says this vbond, which is basically used for authenticating the device. Okay, so as in my earlier videos, I have explained that the edge router first reach out to vbond, and then vbond will authenticate the vh router. Okay, so this is the authenticator. Like in my earlier videos, I have mentioned that the request which was sent for the vbond IP address, okay, when the VH router first come up, it will get its IP address, okay, automatically, and once it get its IP address, it will reach out to vbond.webtela.com, okay, and here it will see the organization. Let's suppose HCL organization vbond. IP address. Once it get the HCL organization VBond IP address, let's suppose 4.4.4.4, then VH router will try to reach to this VBond IP address and try to authenticate itself. And once it will authenticate itself, the VBond will provide the IP address of vmanage and vsmart. Okay, so this is a small short intro which I have given, and that if you want to see the complete explanation of it, you can please go ahead and watch my earlier videos. So the thing which I'm trying to explain is, if VBond says I am from, if this VBond says I am from HCL organization, okay, we need to understand how the VBond can prove that it is from HCL organization. So if the device failed to prove it is from HCL organization, then it cannot join HCL organization SD-WAN fabric. So if the request comes from XYZ organization, then it will reach out to this server looking for XYZ vBond, XYZ organizations vBond. Okay, then once it get the IP address of the vBond for this XYZ organization, or we can say HCL organization, then the edge router will try to reach out to that particular vBond and authenticate itself. This is how the vBond, any vBond which is trying to join the SD-WAN fabric, um, try to authenticate itself and join the SD-WAN fabric. So now we are going to discuss all the security measures need to authenticate a device in SD-WAN solution. Okay, so the security measures which I'm talking about means I'm talking about certificates. Okay, so the certificates are the security measures which are required to authenticate a device so that the device can join the SD-WAN fabric. So the other concept which I'm talking about is, the first one is confidentiality. The second one is integrity. Okay, and the third one is authentication. So these three concepts we require to understand. Okay, and we will discuss these security concepts so that the device can authenticate itself, or device can fulfill the security measures and then join the SD-WAN fabric. Apart from this, we will also understand, or we will also discuss the TLS or DTLS, which means complete security over these tunnels. Okay, so the TLS or DTLS tunnels which will be formed between the edge routers and the controller devices. Okay, so these tunnels are TLS/DTLS. So the first concept is confidentiality. The second one is integrity, and the third is authentication. So this confidentiality means any plain text message sent over the internet can be read by anyone sent over this sent over the transport link. So that means we have this laptop, okay, sending the data over internet, and sending the data to a bank server. So any data which is sent over this link or over this internet link, that data will be that will data will be a plain text data. So that means that can be read by anyone. Okay. So we need to encrypt so we need to encrypt the message sent over this internet transport link. Okay. And that is confidentiality. Okay. So the integrity is means data sent over the transport link should not be changed by anyone. So the data, so the data which is going over this internet link, okay. So if I'm sending A as a data from this source to this destination, okay, this A should not be changed and it will reach to the destination as A only. Okay, so nobody in between can change this data and make it as A dash. Okay, so it should be always be same. The data will always be same, or we can say data sent and data received should be same. No one can alter the message sent over the transport link. Okay, and this authentication is authenticating a device with the help of certificates. Okay, so we're going to discuss each of these security measures one by one in detail. Okay, so starting with confidentiality. So as I mentioned, the plain text message which I'm sending out from my machine. Okay, so the plain text message, this is a laptop sending over the internet transport link towards a bank server. Okay, so the plain text message which I'm sending from a laptop to a bank server, okay, that plain text message can be read by anyone. So what I want is when I send this packet out over the transport link, over this internet link, it should not be changed in a way and it should not be readable, and that means to make the data, to make a plain text data into unreadable form is called ciphertext. Okay, so this is important, ciphertext. Okay, so we will change the data into a form called as ciphertext, and this ciphertext relates to confidentiality. So ciphertext is a data that has been transformed through encryption into a format that is unreadable to unauthorized user. And what is the purpose of it? The purpose is the goal which we want to achieve is to protect the confidentiality of the information, ensuring that only authorized individual with the proper decryption key can access the original plain text data. Okay, so the data which is sending an encrypted over this transport link, okay, and when it reaches a destination, so that data should be decrypted using some particular key only. Okay, so nobody can decrypt this data without this particular key. Okay, so this in this confidentiality, the complete role is to encrypt the data from plain text to ciphertext. Okay, safeguard the sensitive information which is being transport or which is being intercepted or trying to access by unauthorized party during the transmission. Okay, so anybody wants to access this particular data, we have to make sure that data should be encrypted and any unauthorized user cannot access this data. Only the authorized user which has the key can access the data. Okay, I'll tell you an example of that also. So the example is, let's suppose we have a plain text. So the plain text we will be sending is hello world. So we will be converting this plain text into a ciphertext. We will be using a key. Okay, so the my key says to move the letters to 3. Okay, to move the letters to right by 3 number. Okay, so my letters will change to K, H, O, O, R, Z, R, U, O, G. Okay, so changing the letters by plus 3. So H will change it to H, I, J, K. So the K. E will change to E, F, G, H. L, L, O change to M, M, N, O. M, N, O. O change to P, Q, R. So our ciphertext will become Khur, the first for the hello. Okay, and when this ciphertext went through our data, which is Khur rock. Okay, this is the ciphertext which will be converted through the process of encryption by adding a key of plus 3. Okay, so adding 3 letters, then it will be changed to ciphertext. Okay, and when it reaches the destination will decrypt this packet by using minus 3. So it will decrease 3 letters and will get the original data. Okay, so we need to shift 3 letters back on that. So we understand that we need a key value to decrypt the ciphertext to original text. So the whole sole purpose of this confidentiality is you are sending encrypted packets which are not readable to other guys unless they have the right keys. So the message which was in simple text or the plain text, we use key to make it unreadable format. Okay, and the new message will become ciphertext. So we understand this. We converted a plain text message to a ciphertext message with the help of key. Okay, and the algorithm which gonna be used will be is to add the 3 letters to make the message as a ciphertext. And there are many cipher algorithms. So the algorithms are AES, DES. Okay, so this AES is Advanced Encryption Standard, and this DES is Data Encryption Standard. So we understood that encryption is a method of securing the information by converting a plain text into a unreadable ciphertext. And there are two main types of encryption, okay, which are symmetric encryption and asymmetric encryption. So we are going to discuss about both of them now. So there are two type of encryptions. The first one is symmetric encryption, and the second one is asymmetric encryption. So this symmetric encryption means encrypting any message with single key. Okay, and it will be decrypted using the same key. Okay, so in symmetric encryption, the same key is used for both encryption and decryption. We use same key for both encryption and decryption. Okay, but in asymmetric encryption, we will use two keys. Okay, a public key and the second is a private key. So we will use the public key for encryption and private key for decryption. Okay, or vice versa, we can also say that. So in this symmetric encryption, the key must be securely shared between the sender and receiver. Okay, and this symmetric encryption is faster and more efficient than asymmetric encryption. That makes this symmetric encryption suitable for encrypting large amount of data. Okay, so if we want to encrypt bulk data, then as in like the database, we can use the symmetric encryption. So the algorithm used for symmetric encryption, we use AES, Advanced Encryption Standard, DES, Data Encryption Standard, we use triple DES. So in the symmetric encryption, let's take a scenario. We have Alice, we have a person named Alice wants to send a data to Bob. Okay, so Alice wants to send Bob a secure message. Okay, both Alice and Bob agree on a, so they both agreed on a secret key. So both agreed on a secret key, which is 1234. Okay, so Alice encrypt her message, says hello Bob using the same key. The message is hello Bob. Alice encrypt the same message using key which is 1234. Okay, so once it encrypts this message, it will become a ciphertext. So the ciphertext is sent to Bob. Okay, so it become ciphertext. And this ciphertext is sent to Bob. So Bob use this same 1234 key to decrypt the message to get the original message, which is hello Bob. Okay, so we are using a same key to encrypt and decrypt the message. So to encrypt a plain text to a ciphertext and to decrypt a ciphertext to a plain text. Okay, so we use same key for encryption, decryption, and symmetric encryption. So in asymmetric encryption, as I mentioned, we are using two keys, which are public key and private key, to encrypt and decrypt the data, or vice versa. So this asymmetric encryption is slower as compared to symmetric encryption. Okay, but what it eliminates is the need to share a secret key securely. Okay, so here in asymmetric encryption, we can share a key from source to destination securely. The algorithm which we can use in asymmetric encryption is RSA, ECC, or DSA, which is digital signature algorithm. Okay, so we're gonna take the same scenario where Alice wants to send a message to Bob. So Alice wants to send a Bob a secure message. What Bob does, Bob generates two keys. One is public, the other is private. Bob generates two keys which are public and private keys. So Bob share his public key. So this public key, Bob share this key with Alice. Public key. So Bob shared his public key with Alice. So Alice encrypt the message using Bob's public key. So the message which is hello Bob is encrypted by Alice using public key of Bob. Okay. And once this message is encrypted, it will send over the transport link. And once it reaches Bob, Bob decrypt the same message using its private key. Okay. This is how the asymmetric encryption works. So this public key, so the public key which Bob shares with Alice, so this public key can be shared with anyone. Okay, but we cannot share the private key, but we can share the public key over the transport link. So for symmetric and asymmetric encryption, in real world applications for symmetric encryption, we can see a file encryption tools like we can use AES in zip files, or we can see securing a database content, whatever the content is. For asymmetric encryption, we can see HTTPS or TLS connection, transport layer security, or we can say secure shell certificates, email encryption, okay, or this asymmetric encryption is also used in blockchain technology. So in real world, okay, most devices, or we can say most system use both symmetric and asymmetric encryption. Okay, so how both symmetric and asymmetric encryption works. Okay, so this asymmetric encryption is used for the key exchange, to exchange the key, or we can say sharing a symmetric key securely. So securely sharing symmetric securely sharing symmetric keys. So this symmetric encryption is used to encrypt the actual bulk data. So whatever the bulk data is there, which can be in data at rest form, okay, or data transmission form.